Anybody remember?
I think so.
Okay. Chapter 6 sounds about right. In chapter 6, and I do want to make sure you understand this, on your final exam, there will not be section 5. Section 5 is on molecular geometries, so please make sure when you're studying you cross that off. That was one we did not cover. Chapter 6 is all about the different types of bonding and Lewis structures. And so one of the things we had to remember was how to identify valence electrons. And so we came up with a method of counting using locations of where those different metals and nonmetals are on the periodic table. So groups 1 and 2. And then obviously this is 18. When we went through and we were trying to identify numbers of valence electrons, we started on the left and counted over, ignoring the transition metals. Oh. Lewis structures. Here we go. So here are the 3 we are going to draw. You've seen them before. We're going to talk about the steps. First one was to count total valence electrons in the structure. Okay. For CH4, you should get how many for carbon? Okay, somewhere it's located. 4. How many for a hydrogen? Just one hydrogen. 1 hydrogen, but there are how many? 4. So this guy should have 8 valence electrons. Okay, do for nitrogen, or do for NH3. How many should NH3 have?
8.
Correct. About CO2? So 12 plus 4, yep, 16. Okay, next up is to place the least electronegative atom in the center of your structure and bond everything else with a single bond first. So for CH4, it also says to do some accounting, right? So remember that every single bond is 2 electrons, and then there are pairs of electrons, which also equal 2 electrons. So every dot is its own electron, every line is 2 electrons. So how many total do we have? So we have no more to add, right? Okay. Step 3. Fill out our octets with remaining electrons. Do not give hydrogen more than 2. Here's where we also discuss the fact that there are some that have exceptions to that octet rule, right? We said there were exceptions. What were the exceptions?
Phosphorus and after.
Okay, here we go. Exceptions. Anything after phosphorus, good. P after. Can have expanded octets. Okay.
Carbon.
Nope. Carbon always gets an octet.
Boron.
Boron
Golden.
only gets 6 electrons. Okay, what about and then hydrogen and helium? Also only get 2 electrons. Okay. Those were our exceptions to the octet rule.
Are any of those on the final?
Keep accounting. Huh?
Are the exceptions on the final, like not the expanded?
If they are, it'll ask you something like which of the following is an expanded octet. So you'll have to draw them to find out.
So nothing about like boron, beryllium, lithium.
Right.
or-
Usually it's just about the expanded octets. Okay. So the second one says to fill the remaining octets or outer octets with electrons. Don't give your hydrogen any more than 2. So is our carbon hydrogen structure good? Yeah. Okay, what else are we checking for? After step 3, any remaining electrons go where? Anybody remember? This is how we expand the center octet. They go on the center atom. So if after you've done step 3 and you've filled the outer octets, you still have, say, 2 electrons left, those 2 electrons go on the center atom as a lone pair. At this point, you should be done accounting, right? Should be out of atom, no more. Our last step is octet related. Our last step is to move electrons from outer to inner atoms if a center atom does not have an octet. So create double and triple bonds to fill inner octet. Okay, so let's do this one. Ah, does my structure up here have an octet on the center atom?
Yes.
Should carbon have a center octet?
Yes.
So is that a good structure? It has the 8 electrons, it has an octet on carbon, hydrogens only have 2 electrons, does it meet all of our requirements? Correct. All right, let's do this guy. So what atom goes in the center? Nitrogen. Remember, which atom never goes in the center? Hydrogen. So I'm going to attach everything with a single bond. I'm going to do some accounting. I have 8. How many have I added to my structure? I have 2 left. Moving on to my next sentence, it says my next step, fill the outer octets. Do I have to do anything with that, with hydrogens? No, because it's the exception. Section 4 says any remaining electrons go in the center, so these 2 electrons go here. I should have no electrons left to add to my structure. The last thing to do is to check for an octet. Does my center atom have an octet? Is everything else happy? We're good to go. All right, let's do CO2. What atom goes in the center?
Carbon.
Carbon. Why carbon?
This line.
It's less electronegative than oxygen. Remember, in order to determine electronegativity in center atom, we look for the thing furthest away from fluorine. Okay? The thing furthest away from fluorine goes in the middle. All right, next thing is to add the other 2 atoms with single bonds and do some accounting. So 16 minus 4 is 12. Next is to fill outer octets. Do I have to fill outer octets in this particular structure? Can oxygen take an octet? Yes, it can. Here we are at 12 electrons that I've just added, so I have none left. Okay, My next is to any remaining atoms go in the center, but there's nothing left, so I can't do that. So I have to move on to step 5 and figure out what to do about octets. Do my outer atoms have the octets they want? Of course they do. Does my inner atom have its octet? No. So what should I do? Let's move some stuff into our bonds. When we do this, and I was very specific about it in our videos, make sure you redraw them. If you leave it like this, you now have 10 electrons around each oxygen. Okay? Don't do that. Yes?
Does it matter how you place your lone pairs?
Are you asking me if it matters if I do this? No. Means nothing. These structures are essentially meaningless. What they tell us is what happens after this. And what happens after that. And what happens after that. These are a way we approximate what we call bonding theory. Chemical reactions, which is next. Okay? How do we feel about Lewis structures? Are they kind of coming back in our brains? It was a little foggy. It was a while ago. I'm aware. Yes?
On the study guide, it said to like label them polar and non-polar. How
Yeah.
do you like do that?
So what does polar and non-polar mean? Do we remember? So polar and nonpolar were terminology things that we talked about with covalent bonding, where we said a structure was symmetrical or asymmetrical. And we talked about how something being more electronegative than something else meant a structure could be polar or nonpolar. So for instance, if we have these two things bound together, they're identical, right? Is this a symmetrical structure? Yes, it is. Is this a symmetrical structure? Yes, it is. This is nonpolar. Whenever you see something that is symmetrical, it is a nonpolar structure. Okay. Now let's look at is that a symmetrical structure? No, it is not. The lone pair makes it unbalanced. So this is a polar structure. Yes?
So then like on this one, would that be non-polar?
Yeah, if there's a lone pair on the center atom, or two lone pairs on the center atom, it basically means it's an uneven thing.
Okay.
Yep. Yeah, so the question would be then, if I had this, is this still a polar structure? Could you, in theory, draw? I like to think about symmetry and asymmetry as like if I can draw planes. Any way I draw a plane, am I going to get something on one half that's the same on the other? Yes, but anytime there's a lone pair, and it's something to commit to memory, anytime there's a lone pair on the center atom, it is going to be a polar structure. Hands down, no contest. Lone pairs on the center atom mean polar structure. Put that one in your brains. Polarity is something we only talked about briefly in chapter 6, so please don't freak out too much about it. We talked more about polarity with the difference in electronegativities, right? So make sure you can do the difference in electronegativities to identify if something is a polar or nonpolar bond. Don't worry too much about the molecule. It's kind of an obscure thing. What other questions do we have about this? Because this was something we covered remotely. Yes?
Sarah, on the study guide, did you need to put CH4 instead of CH2? Or am I just not doing it right?
I think it was supposed to be CH4, yeah. Because it only has 6 electrons, which would violate the octet. I'm sorry. Typos happen. All right, what else? No? Cool. All right. Yeah?
So for like polar, non-polar, and ionization.
Ooh, yeah.
What are the?
You want to know the numbers?
Yeah.
Yeah, let's talk numbers. Bond polarity. It's an R. This was all about the difference in electronegativities. So when we identify a bond as polar or non-polar or ionic, really what we're missing out when we say that is that there is a spectrum. There's a lot of gray area in between. Something can be very polar if it's towards this end and close to ionic, and something can be almost non-polar and be closer to this end, right? So there's what we call ionic character. That's what this is referred to. It's like percent ionic character. I think that's what it's referred to in your reading. Yeah.
So then will those numbers be given to us, like if we need them?
No.
So we just.
Those are not on my sheets. I don't think I put them anywhere.
Okay.
You would be given the numbers to calculate the differences. So try to commit that one in memory, but that's the only, I would give you other stuff, yes.
Is the 1.8 included in ionic or is it?
So 1.8 or greater, yep. Sorry, should I put greater than 1.7? Is that how math works?
or
Oh, I
greater
don't
than-
do math, I do science, right? Anything that's greater than 1.7, so 1.71 would be ionic. What other questions do you have? If none, I'm gonna let you work more on your study guide, / get ready for some questions for tomorrow, because I will be going over some of those questions tomorrow. If you don't have questions tomorrow, I'm gonna put some cahoots up. I think more of the naming. Remember that naming is something you just learned, so that will be on your final exam. There are, I think, 5 total questions, maybe a little more, because you never took a test on it, or chapter 6. So we'll harp on those a little bit more. Yeah.
Will the prefixes be on there when naming?
Oh, are you talking about the? Yeah. So one of the questions that I've been asked is the molecular version of the compounds, the binary molecular compounds, the one that involves prefixes. Since we didn't go over it in class, it's not in your final exam. The binary molecular compounds, the ones that involve the prefixes, so like mono, di, tri, those are not on there.
Questions on there?
Yeah.
Okay.
They were covered in our videos last semester, or the last week of remote learning, but I did not put it on the final exam. Yes.
I think I really.
Okay. That's what I thought. But like,
Put a parentheses around each one.
I did that. It was like,
yeah, it doesn't really, that's why.
Okay.
That's what I did.
That's why I asked.
I knew the numbers.
Exactly how you see it.
Last year we learned like adding and the.
Oh, yeah, so you can do stuff that way in math. For that one, you would add as you went across and subtract when you went down.
That's what I thought it was, but I was.
It's like the rough math I do in my head all the time. So like I know if you did your math wrong, if your prefixes or if your exponents are wildly wrong.
Got it.
It's the easiest way to tell if you had a calculator error. Because you need to know what the exponent should be. And then if you get something that's like double that, it means you subtracted instead of dividing it or whatever.
so is that what you
So if you want to, you can as you go across and add, so it becomes 3 on the top, and then when you go down, you subtract. They use that for this thing with the So she's talking about when you go across and subtract.
So you can use those?
Good. This one you only went over 5, which I'll come over one. Same with the one on the bottom. 10 to the negative 2 is 0.0.
Yeah.
When I'm trying to find electronegativity.
Yeah, there's a chart. There's like there's a chart in your book of the actual electronegativities, and you're given them. So like there's a periodic table of electronegativities. You want to find that in order to do that.
Wait, Miss Mom, I think it was over.
Oh, so to find it, the absolute value.
Oh yeah, you're right. 6.1. Is that what you're saying?
Yeah. I looked this up and I don't remember explaining
E equals H times E, F is also frequency on this only, so that's,
Okay.
yeah, but this one is asking you what is
Let's just name
the
some.
wavelength, so this one
First
can
150 in order.
What's the speed of light?
Okay.
This one, yes, so E equals H times F, frequency.
And then,
This is frequency,
okay.
and this is weight.
It's like 8 minutes.
And then, will this one be on the,
So your formula sheet, if you haven't already,
alright.
boys and girls, make sure you open your formula sheet tonight so you can identify what you have. Be familiar with them. If you have questions, we can talk about it tomorrow. I think I got them all.